Welcome, everyone. Today we're jumping into something, well, fundamental, your brain, how it works, how we can make it work better. You've probably heard that old saying, right? That we only use, 10% of our brain power. It paints this picture of this huge untapped potential just sitting there. But is that really how it works?
Yeah, that 10% idea is, it's one of those myths that just sticks around. It sounds kind of cool, I guess. But the reality, based on everything we know, is that healthy humans use pretty much 100% of their brain, almost all the time.
100%, really?
Yep. Think about brain imaging, like fMRI scans. They show activity across the whole brain, even when you're resting. And look at brain damage studies. If 90% was unused, then damaging those areas wouldn't really matter much, right?
Right, yeah, that makes sense. But even minor brain injuries can have huge effects.
Exactly. Damage to almost any area causes noticeable problems. So where did the 10% myth come from? Well, one idea is it might be a misunderstanding of brain cells. Only about 10% of your brain cells are neurons, the ones doing the main information processing, the thinking, the transmitting signals.
Okay, so what's the other 90%? Just filler.
No, not at all. The other 90% are mostly glial cells, and they're incredibly important. They support, insulate, clean up waste, and even help the neurons communicate effectively.
So it's not unused potential, it's just different roles for different cells.
Precisely. It's not about unlocking some hidden vault. The real key is understanding how we use the whole amazing thing we've got.
Okay, that totally reframes things. So if we're already using all of it, then how do we explain learning, getting better at things, like learning guitar or a new language? How does the brain accommodate that?
That's the magic word, really accommodation, or rather adaptation. It leads us straight into neuroplasticity.
Neuroplasticity. Heard that term a lot. What does it actually mean in simple terms?
It's the brain's incredible ability to change itself, to reorganize its structure, its connections, its functions, all throughout your life. It happens in response to everything, really learning new things, your experiences, practicing skills, even recovering from injury.
So the old idea that your brain is basically fixed once you're an adult, that's just wrong.
Completely wrong. That's outdated thinking. Your brain is constantly dynamically changing. It's never static, not even when you're asleep or just zoning out. And importantly, this capacity for change doesn't just disappear with age.
That's actually really hopeful. So how does it change? Like what's happening on a physical level?
Yeah, so there are three main ways the brain changes to support learning. First up are chemical changes.
Chemical, like neurotransmitters.
Exactly. Your brain can quickly boost the chemical signals between neurons. Think of it like turning up the volume temporarily. This is great for short-term stuff, like remembering a phone number just long enough to dial it, or how you might get slightly better at a video game within one session. Short bursts of improvement.
Okay, quick boosts. What else?
Then you have structural changes, and these are the big ones for long-term learning. This is where the brain physically alters the connections, the synapses between neurons.
It actually rewires itself.
Literally, it strengthens connections that are used often, builds new ones, and sometimes prunes away connections that aren't being used. This takes more time, obviously.
Wow. Are there examples of this?
Oh, yeah, absolutely. Classic examples include people who read Braille. The area of their brain processing touch for their reading fingers actually gets larger.
So it physically grows.
Representation expands, yeah. And London taxi drivers, the ones who have to memorize that incredibly complex city map, the knowledge, studies show they have a significantly larger hippocampus, which is a key area for spatial memory. Their brains physically changed because of what they needed to learn and do.
That's wild. So chemical, structural. That's the third one.
The third is functional changes. Think of it like carving a path in the woods. The more you use a specific neural pathway, the easier and more efficient it becomes to use again.
Makes it easier to activate that skill or thought.
Exactly. The brain region involved becomes more excitable, more readily available. Entire networks shift how they operate as you learn, becoming more streamlined. Often, all three types of changes, chemical, structural, functional, are happening together to support learning.
Okay, so this neuroplasticity sounds amazing for learning piano or remembering facts.
Yeah.
But you said it responds to everything. Does that mean it can? Well, change in bad ways too.
That's a really important point, yes. Neuroplasticity is neutral, it just adapts. So while it helps us learn good things, it's also the mechanism behind negative patterns.
Like what?
Well, forgetting things you want to remember is a form of plasticity. Addiction involves the brain rewiring itself, strengthening pathways related to the substance or behavior, making it harder to resist.
Wow.
And chronic pain is another example. Sometimes the brain gets stuck maintaining pain signals even after the original injury has healed. It's learned the pain pathway too well.
So the brain's adaptability can kind of backfire.
It can. And the crucial thing driving all this change, good or bad, is your behavior. What you do, what you practice, what you pay attention to.
So there's no magic pill for boosting brain power.
Nope. There's no neuroplasticity drug. Practice, repetition, focus. That's what drives the changes. And interestingly, a bit of struggle seems to be good.
Struggle, like when something feels hard?
Yeah, exactly. When you're really wrestling with a problem or a new skill, when it feels effortful, that difficulty actually signals the brain that this is important, triggering more significant structural changes. So don't shy away from the challenge.
Okay. Embrace the struggle. Noted. So if behavior is the key, what are some practical, good things we can do? Things that actually exercise the brain in useful ways?
Great question. There are lots of things, many of them quite enjoyable. Let's talk about some targeted brain exercises.
Beyond just Sudoku, though I do like Sudoku.
Sudoku's good too. We'll get to that. But things like the Schulte table, ever heard of it?
Schulte table? No, what's that?
It's simple, really. A grid with numbers, usually 1 to 25, all mixed up. Your goal is to find and point to them in order. 1, 2, 3, as fast as you can. Aiming for maybe under 30 seconds.
And that helps.
It forces your brain to process information rapidly, improves your peripheral vision because you're scanning the whole grid, and boosts concentration. Simple but effective.
Okay. What else?
Another one is the multicolor text exercise. You see a word like BLUE, but it's written in, say, red ink. Your task is to say the color of the ink, red, not read the word blue.
Oh, like the Stroop test. That's surprisingly hard.
It is, and that difficulty is good. It forces your prefrontal cortex to override your automatic reading response. It strengthens focus, working memory, and your ability to switch tasks.
Interesting. What about using our body more?
Absolutely. Engaging your senses and body in novel ways is fantastic for building connections. Try simple things blindfolded sometime.
Like what? Eating.
You could try eating. Or maybe start with writing your name or drawing basic shapes. It forces your brain to rely more on spatial memory and internal representation.
Okay, maybe not eating blindfolded right away.
Maybe not. Or try hand coordination stuff, like make a peace sign, thumb, and index finger circle, other fingers up with one hand.
Okay, got it.
And an OK sign, just the thumb and index finger circle with the other hand.
Right.
Now switch them, quickly, back and forth.
Oh, wow, okay,
Yeah,
that's harder than it sounds. My brain is short-circuiting.
See? It forces new connections, even simpler. Just use your non-dominant hand for everyday tasks. Brushing teeth, using your mouse, stirring coffee.
It feels so awkward, though.
It does. But that awkwardness is the brain building new pathways, waking up areas it doesn't usually rely on for that task.
Okay, non-dominant hand brushing tonight, maybe. And you mentioned brain games.
Yes, things like Sudoku, chess, crosswords, riddles, word scrambles, they're all excellent. They push your decision-making skills, logic, and memory. And there's actual research showing that older adults who regularly do puzzles like Sudoku and crosswords tend to experience memory decline later than those who don't. It's like mental gymnastics.
Keeps things flexible. What about writing? Does typing count?
Typing is fine, but research suggests writing things down by hand is actually more effective for learning and memory.
Really? Why?
Because you can't write as fast as you type usually, so you have to process the information more deeply, select what's important, rephrase it in your own way. That deeper processing locks it in better.
That makes sense. You have to summarize and filter more.
Exactly. And journaling, just writing about your day or your thoughts, is great for strengthening the language areas of your brain too.
And one more, utilizing dead time.
Yeah, think about all those times you're kind of passive. Commuting, walking, waiting in line. Instead of scrolling social media, maybe pop on an educational audiobook or a podcast like this one.
Turn passive time into active learning.
Precisely. It's about weaving brain-building activities into the nooks and crannies of your day.
This is a lot of great stuff, lots of activity for the brain. But sometimes the issue isn't what to do, but actually getting focused enough to do it. How do we manage focus?
Yes. Focus. That brings us to the idea of the flow state. Heard of that?
Yeah, like being in the zone, where time disappears and you're just completely absorbed.
That's exactly it. It's a state of peak performance and concentration. You're fully immersed, hyper-focused, energized by the task itself. And neurologically, what's happening is pretty cool. Your brain can process roughly 110 bits of information per second. Just listening to me talk now probably takes about 60 bits for you to process.
Okay.
In a flow state, your brain dedicates all 110 bits to the task at hand. There's literally no processing power left for distractions, which is why the outside world seems to just fade away.
Wow. So how do we get there? Can we trigger it?
You can definitely set the stage for it. There are key conditions. First is the challenge-skill balance.
Meaning?
The task needs to be challenging enough to engage you fully, but not so hard that it causes anxiety or frustration. You also need to feel confident in your skills to meet the challenge. Too easy, you get bored. Too hard, you get stressed. Flow is in that sweet spot.
Find the sweet spot. Got it. What else?
Optimize your conditions. Figure out when you're naturally most productive, morning, afternoon, late night. Make sure you're not hungry or tired. And crucially, eliminate distractions. This is huge. Phone off or in another room. No email pop-ups. Turn off the TV. Clean up your workspace so you're not visually distracted. Gather everything you need before you start so you don't have to interrupt yourself.
Create a focus bubble.
Exactly. And finally, have specific goals for the session. Don't just sit down to work on the project. Decide, I'm going to outline chapter 3 or I'm going to solve these 5 specific problems. And be patient. It usually takes about 15 minutes or so of solid, uninterrupted focus to really drop into that flow state. There's a warm-up period.
15 minutes. Okay, that feels doable. Yeah. But sometimes even getting through those first few minutes feels like wading through mud. That initial friction. Is that normal?
Totally normal. In fact, it's often necessary. Some experts call it the agitation gateway.
Agitation gateway. Sounds ominous.
Maybe a little. But it just refers to that initial feeling of stress, frustration, maybe confusion when you start tackling something hard or requiring deep focus. It's a natural neurochemical reaction. Your brain is shifting gears, activating the necessary networks, maybe releasing a bit of adrenaline or norepinephrine. You have to push through that initial discomfort to get to the focused state on the other side.
So don't bail when it feels hard at first.
Exactly. Recognize it as part of the process. And this is where dopamine comes in.
The reward chemical.
Kind of. It's more about motivation and drive. Dopamine gets released when you achieve a small goal, make progress, or even just believe you're on the right track towards your goal. And that dopamine hit actually helps suppress the quit signals, the stress chemicals like norepinephrine, giving you the energy and drive to keep going to stay focused.
So small wins help build momentum.
Yes. But the key is learning to self-reward the effort itself. Don't just rely on finishing the whole project or getting external praise. Internally acknowledge the effort. Okay, this is tough, but I'm sticking with it. Nice, I figured out that paragraph. Relying only on external rewards can actually decrease your internal motivation over time. Find the satisfaction in the process, in the focus itself. That internal reward loop is much more powerful for sustaining effort.
Learning to reward the struggle, not just the outcome. That's a shift. Okay, so we have these active strategies, focus techniques. What about the baseline, the everyday stuff that supports all this?
Absolutely crucial. The foundation. We're talking basic lifestyle pillars. Number 1, sleep.
Always comes back to sleep, doesn't it?
It really does, especially for the brain. Sleep isn't passive downtime. Your brain is incredibly active, consolidating memories, linking ideas, and crucially, during deep sleep, the brain activates its cleaning system, the glymphatic system. It clears out metabolic waste products that build up during the day.
Waste product.
Yeah, things like beta amyloid plaques, which are strongly linked to Alzheimer's disease. Sleep literally pressure washes your brain.
Oh, wow. Pressure washes your brain. I like that.
Lack of sleep messes with everything. Judgment, decision-making, attention, alertness, mood, memory formation, and consistent chronic sleep restriction is actually more damaging long-term than pulling a single all-nighter. Consistency is key.
Okay, prioritize sleep. Pillar number 2.
Diet. And again, consistency and patterns are more important than chasing miracle superfoods.
So what kind of pattern?
Think generally healthy. Lots of fruits and vegetables get a variety of colors in there, like berries, leafy greens, healthy fats like olive oil, fish, beans, nuts, walnuts seem particularly good for brain health.
Good fats.
And limit the stuff we know isn't great. Red and processed meats, too much added sugar and salt, high-fat dairy like butter and cheese in excess, refined grains like white bread. It really boils down to what's good for your heart and body is generally good for your brain. Simple, but true.
Makes sense. Body and brain are connected. And the third pillar?
Physical exercise. This is a huge one for the brain. Exercise is like a wonder drug for neuroplasticity.
How does it work?
It boosts critical biochemicals. One is BDNF, brain-derived neurotrophic factor. Think of it as fertilizer for your neurons, helping them grow, survive, and form new connections.
Brain fertilizer. Nice.
And another is VEGF, vascular endothelial growth factor. This helps build more tiny blood vessels in the brain. Better blood flow means more oxygen and glucose delivered to your brain cells, which fuels everything.
So exercise directly helps the brain build and fuel itself.
Absolutely. It enhances learning, memory, and can even increase the actual volume of your brain, both gray matter, the neurons, and white matter, the connections. Plus, exercise is proven to improve mood and cognitive function in conditions like ADHD, anxiety, and depression. It can even offer some protection against things like stroke and Alzheimer's.
How much exercise are we talking? Hours in the gym?
Not necessarily. Even moderate activity helps. Some studies suggest just 12 minutes of activity can give a noticeable boost to brain power, maybe by 30% shortly afterwards. The key is making it a regular habit.
Sleep, diet, exercise. The foundations.
Got it.
So, assuming we're building this healthy, adaptable, focused brain, how do we use it wisely? How do we think better, especially when things are complex or confusing?
That's where critical thinking comes into play. It's about more than just being smart. It's a skill set, a process.
Define critical thinking for us.
It's the ability to analyze information objectively from multiple viewpoints to reach the best possible, well-reasoned conclusion. It means actively questioning assumptions, especially your own assumptions and biases.
So it's about questioning things.
And evaluating evidence. Key skills include things like analytical thinking, being open-minded to different perspectives, logical reasoning, problem solving, and making sound judgments based on evidence, not just gut feeling or emotion.
Okay, sounds important. Is there a way to practice it, like a method?
There is. The sources often lay out a kind of 7-step process. It might sound a bit formal, but the steps are logical.
Let's hear them.
1. Identify the problem or question clearly. And right at the start, try to acknowledge your own potential biases about it. Be honest with yourself.
Step 1. Know the question, check your bias.
2. Gather relevant information. Look at different sources, diverse perspectives. Actively seek out info that might challenge your initial view.
Don't just look for confirmation.
Exactly. 3. Analyze and evaluate that information. Is it credible? Is it relevant? How significant is this piece of data versus that one? 4. Consider alternative interpretations or points of view. Put yourself in someone else's shoes. How might they see this differently? Challenge your own framework.
Okay.
5. Draw logical conclusions. Based on the evaluated evidence, what makes the most sense? Connect the dots. Look for cause and effect. Aim for objectivity.
Step 6.
Develop and communicate solutions or your conclusion. Be able to explain your reasoning clearly to others.
And finally,
7. Reflect and learn. Look back at the process. How did it go? Was the outcome good? What could you do better next time? Apply the lessons. It's a cycle.
identify, gather, analyze, consider alternatives, conclude, communicate, reflect. That's a solid framework.
It provides structure for thinking more clearly and reducing bias.
That's great for analytical problems, but what about those times you need more? Intuition or creativity. Can we leverage the brain for that too?
Definitely. You can actually work with your subconscious mind to tap into deeper insights. There's a process for that too, sometimes called incubation.
Incubation, like hatching an idea.
Sort of. First, you need to target the subconscious. Clearly define the problem or the question you want an answer to. Be specific. For example, not just how do I get better at my job, but maybe what's one specific skill I could develop to add more value to my team?
Okay, specific question.
Then, and this is key, write it down. Physically writing it seems to flag it as important for your brain, telling your subconscious networks to keep working on it in the background.
Writing it down tells the brain, this matters.
Pretty much. Next comes the incubation part. You deliberately step away from consciously thinking about the problem.
Do nothing.
Not nothing, but engage in low-intensity, maybe slightly distracting activities. Go for a walk, take a shower, do the dishes, light exercise. Avoid anything mentally demanding like intense work or complex games.
Why low intensity?
It occupies your conscious mind just enough to let your subconscious go to work without interference. It can run simulations, connect disparate ideas, access memories, things your conscious mind might filter out. This can take minutes, hours, sometimes even days or weeks.
Let the back burner simmer.
Exactly. Then the final step is to retrieve the answers. After some incubation time, sit down with the intention of solving the problem. Maybe you just start writing or doodling related to it. Often the insight or solution will just pop into your head. It feels like it comes out of nowhere, but it's the result of that subconscious processing.
Wow. So prime the pump, let it simmer, then be ready to catch the idea.
It's a powerful way to leverage the brain's deeper processing abilities. And related to this is mental rehearsal.
Visualizing success.
Yes, but it's more than just wishful thinking. When you vividly imagine yourself performing an action successfully, say, giving a presentation, making a difficult phone call, sinking a basketball shot, your brain activates many of the same neural circuits as actually doing it.
So the brain practices even without the body moving.
In a way, yes. It installs the neurological software for that action. It maps your brain towards that future success, making the actual performance feel more familiar and achievable when the time comes.
Amazing. Okay, this has been quite a journey through our own heads. We started by busting the 10% myth.
Realizing we use almost all of it.
Then explored neuroplasticity, how the brain physically changes through chemical, structural, and functional shifts based on what we do.
And how that change can be positive or negative, driven by our behavior.
We covered a ton of practical things. Brain exercises like Shilta tables, using our non-dominant hand, the power of handwriting.
And the importance of getting into that focused flow state, pushing through the agitation gateway.
Plus the absolute necessity of the lifestyle pillars. Sleep, healthy eating, and physical exercise.
The foundations for everything else.
And finally, sharpening our critical thinking with that 7-step process, and even tapping into our subconscious for intuitive insights and using mental rehearsal.
It really underscores how incredibly adaptable, how plastic your brain is. It's constantly being molded structurally and functionally by your actions, your thoughts, your environment, even by what you choose not to do.
So much agency.
And it highlights the idea of personalized learning. What works best for you might differ from someone else, or even differ for you depending on what you're trying to learn. So pay attention to how you learn best. Understand your own brain.
A powerful closing thought. Which leads us to the final question for you, the listener. Knowing that your brain is constantly being shaped right now by everything you do, what's one specific healthy behavior you'll choose to implement, starting today, to actively build the brain you want for tomorrow?